A second way to calculate it is using standard free energy values. Just like we use standard entropy values to calculate a change in entropy, and we did the same thing with enthalpy in 161. Here we're going to use standard free energy values that you would look up in a table or given to you here to calculate based on our chemical formula that's balanced. I can take the sum of my products all multiplied by their coefficients and subtract the sum of my reactants multiplied by their coefficients. So these are all at 298 degrees Celsius on this table, and we've got units of kilojoules per mole. So let's look at our example for this. And I've copied over part of the table here. So we have our Gibbs free energy standard values to the right. So we're looking at a reaction between methane and oxygen forming carbon dioxide, water, and ozone. So this is a combustion reaction. So looking at my table right here, I'm going to make sure I'm matching up my chemical formula and the phase it's in with my Gibbs free energy value. So I have methane right here at negative 50.5. I've got oxygen gas here. I've got carbon dioxide gas, water, and ozone. So I'll be using all of these values. Okay, so let's set this up. I have my Gibbs free energy. That's going to be equal to the sum of my products times their coefficients. So I'm starting with my products right here. I've got carbon dioxide, water, and ozone. Those correspond to these values right here. So my carbon dioxide, I only have one of those for my coefficient. So it's 1 times my value of negative 394.4 kilojoules per mole. I'm going to add to that 2, since I have a coefficient of 2 in front of my water molecule, 2 times my water value of negative 228.6 kilojoules per mole. And then I'm going to add my ozone. I've got 4 of those actually. So I've got 4 ozone molecules in my balanced reaction. So I'll start with a 4 and multiply that by my value of 163.2 kilojoules per mole. Okay, that handles the products. Now, from the sum of those, I'm going to subtract the reactants, which I'll do in the same way. So my reactants now are going to be my methane and my oxygen, which are right here. So I'll take the sum of those. My methane, I only have 1, a coefficient of 1 in my balanced reaction. And I have a value of negative 50.5 kilojoules per mole. I'm going to add to that 8, since I have a coefficient of 8 under my oxygen, times my entropy, or sorry, my free energy value, which is 0 because it's an element. And so 0 kilojoules per mole. And that'll be it. So now I can plug this into my calculator. And when I do, I'm going to get a value that is negative 148.3 kilojoules, which is spontaneous. That delta G is less than 0, so I have a spontaneous reaction.